Okay, so this is the last video of Unit 3. I'll be discussing subderivations in this video, doing a few derivations involving subderivations, and summarizing what we've learned so far. So what's a subderivation? Well, suppose you saw this argument. You had if P, then if Q, then R, and not R, then if Q, then P. Well, this argument is derivable, but you need to do a subderivation. And what is a subderivation? It's a derivation inside of a derivation. So let's go and take a look actually at a subderivation, an argument involving a subderivation. This is not actually the one I wanted. Let's see. Is that it? No? Okay, let's look one more place. There we go. Okay. Oh. We don't want that though. We're going to delete the work. Okay, so this is the argument that we were looking at just previously. So we'll say show conclusion. The caps doesn't matter. In chapters 1 and 2, all of our symbols are in caps, and so it's easier to leave things in caps because if you type in here anything, you don't need to worry about pressing shift. Anyway, so we'll say assume CD because it's a conditional. We're trying to show a conditional, we want to make an assumption, and if it's a conditional, we do want to make a conditional assumption. Why is that? Well, if we did assume ID, we'd have the negation of a conditional. And what can we do with that? Well, in this case, not much. In particular, you can never do modus ponens or modus tollens with the negation of a conditional. You need the conditional. So assuming ID when you're trying to show a conditional is going to get you something you can't work with, at least right now. So assume CD, we get our antecedent. Now we bring in premise 1 and premise 2. Now, where do we want to get to? Well, we want to box and cancel. Remember, that's always our goal. And what kind of thing are we trying to show? We're trying to show a conditional. So if we get not P, we can box and cancel by CD. So getting not P would be really useful. But the problem is, we can't use any of our inference rules at this point. We're stuck, right? This conditional, well, we need P to do modus ponens. We don't have P, we have Q, and we have not R. For modus tollens, we need the negation of this, so we need that. But we don't have that either. We have Q and we have not R. So we can't with this and that do modus ponens or modus tollens, and we can't with this and that do modus ponens or modus tollens. So what we need to do is a subderivation. So what's the subderivation that we're going to do? Well, so we type in show again, just like we did before. Now what do we want to show? Well, what would let us finish the derivation? Not P, right? Because then we could box and cancel the main. If we got not P somehow, then we could say, oh, good, we're done, because that's the consequent. So it would be really nice to get not P. So that's what we want to show. We want to show not P. And in fact, we so frequently want to do that. If we're trying to show a conditional, it's always going to be a good idea to getting the consequent will always let us box and cancel. So it's always a good idea to try and show it. And so there's a show command. Just like we have the show conclusion command, show conc always puts in the conclusion. If we're trying to show a conditional here, then we can say show consequent. Show cons for show consequent. And we get a new show line. Now, remember, is this the justification for that line? No. Show lines do not have or require justifications, because when you write down the show line, all you're doing is saying, I'm trying to show this. And so, right, this show line is fine, even though there's no justification. Don't worry about why that question mark is there. So here, right, if we look, we do get an error message that says it's not yet canceled, but it doesn't say you can't write it down. It says you just haven't canceled it yet. So what we want to do is we want to show the consequent of the conditional we're trying to show. Now, whenever we put in a show line, we can make an assumption. You can only make an assumption immediately after a show line. So whenever you put in a show line as a subderivation as well as the main show line of the derivation, you want to make an assumption. So what assumption shall we make? Can we make a CD assumption? No, you can only make CD assumption if you're trying to show a conditional, and we're not. So we will make what kind of assumption? An indirect assumption. Let's choose the unnegated form. So we have P. Now we're in good shape. We want to say, once you write a show line, you get to make an assumption, and then you want to go back and look, okay, I have this new assumption, can I use it? Can it help me with, does it interact with any of the stuff I already have? And if you've made a good decision for your show line, it probably will. So in particular, we can see P is the, which we have on line 6, is the antecedent of line 3. So we'll say 3, 6, modus ponens, and we have if Q then not R. Now, can we use if Q then R? Indeed we can, because what do we need for modus ponens with if Q then R? We need Q. Do we have Q? Yes, we have Q on line 2, so we can say 2, 7 modus ponens, and that gives us R. Okay, good. So we're moving along. Now what can we do with R? Well, boxing and canceling is always a good thing, and there's not R on line 4. So we now have a contradiction. And why do we care about contradictions? Because they let us box and cancel with ID. Now each show line needs to be separately canceled. So we might want to say 4, 8 ID. Now if we do, it says, oh no, you can't do that. Why not? Line 4 is not within the current subderivation. In other words, line 4 is not down here. So this is why we have this. There's a requirement that when you box and cancel, the lines you cite for boxing and canceling have to be beneath the show line. We're not going to worry about why that's a requirement, it just is. If you box and cancel by a show line, how do you do that? The lines you cite have to be beneath the show line. So we're going to do 4R. And that's the only reason we use the repetition rule. It's to get the lines that we cite for boxing and canceling beneath the show line. So we have 8 and 9 now as a contradiction. That's an indirect derivation. And we can box and cancel line 5. Now you only box and cancel one show line at a time. So what's happened here is we were working on this, we went in here and we got a contradiction and we said, okay, indirect derivation. And so that show line, the one we were directly beneath, was canceled. This show line up here, still not canceled. But this show line has been. And this stuff has been boxed. And I can explain now why we box things. The reason is that this reasoning, these lines, may, and in fact in this case do, depend upon this assumption. Now, making this assumption for showing not P is perfectly legitimate, but it's not really a good idea to make this assumption. In fact, it's a bad idea to make this to assume P while you're working on showing that. So this reasoning depends upon an assumption, and that assumption is okay for showing this. But we've canceled that. We've shown it, we're no longer showing it, and so we don't want to rely on P anymore, and we don't want to rely on any reasoning that comes from P. So we box this stuff to dramatize that we cannot refer to it anymore. If I were to say, okay, line, say, 6, 3 MP, I get the message line 6 is already boxed, or should be, and that means you can't use it. So the boxing stuff gets boxed to indicate you can't use it, and the reason you can't use it is because it may depend upon an assumption that was fine in the context of showing something, but you're not in that particular context anymore, and so it's no longer legitimate to rely on that assumption. And to help us remember that we can't use that stuff, we can click this triangle, and it actually just hides all that stuff. So now we want to look at what we have, in which we have not P. Now why, when we think back, did we try to show not P? We didn't just show not P. I mean, it's nice that it gave us the assumption, but we didn't, and if you choose your subderivation wisely, the assumption you get to make will help you complete the subderivation. But we didn't complete the subderivation we didn't do the subderivation for fun. We did the subderivation because once we were done with it, we could do something with it. Once we said, I'm going to try to show this not P. Why? Because when I have not P, that will be helpful somehow in the main derivation. So the question is, why is it helpful to show not P in the main derivation? How does not P help us in the derivation? Now we're back working on this show line. How does not P help us? This tells us. The command, the shortcut command, not only sort of regularly puts in a certain sort of thing, but there's always a reason. There's a strategic reason for why we did this, and it's because this is the consequent of this conditional that we're trying to show. And if you have the consequent of a conditional, what can you do? You can do CD. Right. On line 5, once the show line is canceled, before the show line is canceled, we can't cite it. But once it's canceled, we can use it. We've established it. And how is it helpful? Well, this is the consequent of that, and that lets you. And so you can box and cancel this by referring to this. And so this derivation is now complete. So that's an example of a subderivation. So let's look at a, we'll look at a couple more, just a few more derivations involving subderivations. Yes, we're going to save that. Let's go to 1.6. This one. Okay. So we're going to show the conclusion. Should we make an assumption? In this case, we actually don't need to, but we might as well, since it's a good habit to be in. We can't do a conditional assumption, so it's an indirect assumption. Okay. So let's bring in our premises. You don't have to bring them in. You can cite them directly with rules, but it's helpful to have them displayed like this, so you can see them all. So not S. Can we do anything with not S? Well, let's look at 3. If P then Q, do we have P? No, so no modus ponens. Do we have not Q? No, so no modus tollens. Do we have Q, the antecedent of 4? No, so no modus ponens. Do we have the negation of the consequent of 4? That would be not R. No, we don't, so no modus tollens. 5. If P, that's a conditional. The antecedent is if P then R. Do we have if P then R? No. Could we get if P then R? We should be able to get if P then R from 3 and 4. So that might be one thing to think about. But more immediately, what about the consequent? Well, it's S. So what do we need for modus tollens? Not S. Do we have not S? Yes, we do on line 2. So we can say 2, 5 modus tollens. That moves us forward a little bit. But now we're kind of stuck because we can't do modus ponens or modus tollens with line 6 because it's a negation of a conditional, and you can only do modus ponens or modus tollens with a conditional, not the negation of a conditional. So, and we already discovered we couldn't do modus ponens or modus tollens with 3 or 4. And we've already used up line 5. So now, things are kind of sticky, right? So what should we do? We're stuck. And that's when you do a subderivation. You do a subderivation when your inference rules won't get you anywhere and you're stuck. And you think, okay, if I'm stuck, I can't do anything with my inference rules. That's one good time at which to do a subderivation. Previously, in the previous derivation, we said, oh, we're trying to show a conditional, let's show the consequent. That's always a good idea to do. That's sort of automatic. But when you're stuck is another time to do a subderivation. So in this case, what we want to show is P then R. Now you might think, why are we going to do that? Oh, for modus ponens with line 5. And that's one thing we could do with it, but it's actually even more direct than that, because once we complete this derivation, look at line 6 and 7. We have a sentence, if P then R, on line 7, and its negation on line 6, so we can say 6, 7 indirect derivation, and we'll be done, right? Because that's a contradiction, and that's all we need for a indirect derivation. So we're going to do show of P then R. So we'll say assume CD. Now we could say show the consequent again, because we're trying to show a conditional, and that would be show R, and assume ID. That's not necessary in this case. It wouldn't hurt us to do that. It just makes the derivation a little bit longer. But we don't need to do that, so we're not going to. I just wanted to show you that that was a possibility, but it's not necessary in this case. So we want to look, can we use P? Yes, we can. We can use P with line 3. Gives us Q, right? There's if P then Q. We have P, so when we apply modus ponens, we get Q. Can we use Q? Yes, we can use Q with 4 and do another modus ponens. So we can say 4, 9 modus ponens. We get R. Can we do anything with R? Yes, we can. No inference rule applications, but we can box and cancel line 7. So paying attention to what we're working on will help us remember how we might box and cancel. So there we go, 10 CD. And why did we do 7? Because it contradicts 6. So we can say 6, 7 ID. And there we go. We've done it. So here we did this subderivation because it contradicted this. And in fact, there's even a show command for it. If you have a conditional, a negated conditional, if you show the unnegation of the conditional, if you show the conditional, then you can box and cancel for ID. So if you say show unneg, well, of what? Show unneg of line 6, it will even stick it in for you, right? This is just repeating what we did, right? So this strategy of if you have a negated conditional, then show the unnegation of the conditional, is a good strategy, because when you're done with it, you can, as we saw before, do the indirect derivation, because you have a contradiction here between if p then r and not if p then r. I'm going to do just one more, and then finish off with some more sort of general comments about these derivations, about derivation strategy. So again, we're going to say show conclusion. It's a conditional, so we'll make a conditional assumption. We're trying to show a conditional, so let's show the consequent. Whenever you have a show line, you want to make an assumption, so we'll make an indirect assumption. So now we have not r and not q, and let's bring in the premise. So we have if p then not r, then q. So for modus ponens, what would we need? We would need if p then not r. For modus tollens, we would need q. Do we have if p then not r? No. Do we have not q? Yes, we do. 4, 5, modus tollens, and we get the negation of the antecedent. So we get not if p then not r. Okay. So what are we going to do? We're stuck again, right? There are no good inference rule applications we can make. We've used line 5. We did modus tollens with it, so it's probably done with. Not r, not q can't get us anywhere. What about line 6? Can we do modus ponens with line 6? No, because it's not a conditional. It's the negation of a conditional. And for the same reason, we can't do modus tollens. So we're stuck. No inference rule application. So we need to do something else. Well, that means we have to do a subderivation. Okay, good. So what subderivation is going to, once we're done with it, it's going to help us finish the derivation? Well, if we can box and cancel line 3, that's q. That's the consequent of line 1. So once we box and cancel line 3, we're done. So we want something that's going to help us box and cancel line 3. Okay. What's going to help us box and cancel line 3? Well, if we're doing an indirect derivation, then a contradiction will help us box and cancel line 3. Okay. So we want a contradiction. Well, what can we get a contradiction with? Well, with 2, 4, 5, or 6. So if we have not r, so if we could get r or not r, we would have a contradiction. If we could get q or not q, we'd have a contradiction with line 4. Or if we get a contradiction with line 6, if we had if p then not r, then we'd be done. Well, that's what we want to do. We want to do show a negation of 6. Why do I know that? I know that because I know that the only way we're going to have to use line 6, and right now the only way we can use line 6 is in citing it to box and cancel indirectly. There are other ways we might be able to use line 2 and line 4. We've already used line 4 once, and we may be able to use line 2. But line 6, there's not going to be much we can do with that besides using it to box and cancel with indirect derivation and a contradiction. And that's when we're done with line 7. That's what we'll be able to do. So we can say assume CD. Now what do we need to box in? We could say show consequent, right? Because why? Well, once we get the consequent of line 7, we can box and cancel with CD. But what is the consequent of line 7? It's not R. Do we have not R? We already have not R. So we can just repeat so we could say 2CD, except we can't because line 2 is not within the current subderivation. So instead we're going to repeat R. So let's get rid of this line. We don't want that. And in fact, we don't even need this. All we need is not R. And we can say 8CD. Remember, as I noted, when you box and cancel, the box and canceling doesn't care about the assumption. You can box and cancel with CD as long as you have the consequent. It doesn't matter how you got the consequent. And same thing with contradictions in indirect derivation. It doesn't matter where the contradiction came from. As long as you have a contradiction, that's sufficient. So we have not R, and that's the consequent of line 7. So we repeat it on line 8, and we cite it for CD. And so we can box and cancel line 7. Now that means we don't care about what's inside of this subderivation anymore. But what we do see is, okay, why did we finish this? Why did we do this? Because this is the unnegation of line 6, right? And is it the unnegation? Yes, because there's a negated thing, and here's the thing without the negation. And that means we have a contradiction on line 6 and 7, and what can you do with a contradiction? You can cite them for indirect derivation, and that means we now have line 3, because that's the thing we were working inside of, and that means we can say CD. And we are done, because Q is the consequent of line 1. So that's our last example of doing a subderivation. So let me actually finish expanding that. I'll print this out and put this online. Let's hop back to our keynotes. So the general idea here is you do a subderivation, it's a derivation inside of a derivation. And you can write any show line you want. Show blah for any blah. Why? Because all that means is that you're trying to show it. Now, if you don't choose the right, if you don't make a good choice, then you won't be able to show the thing you're trying to show, and you'll have to delete it. But it's not a there's no justification needed. So what you need to do is figure out what subderivation do I want to do? What is going to help? Now, you can't cite the show line until you've completed the subderivation. Because this is a consequence of the fact that show lines don't have any justification. All you're trying to do is trying to show it. So you can't cite the line until you've succeeded in showing it, and what's showing it, boxing and canceling it. Once you have boxed and canceled the lines, box and cancel the show line, you can't cite the lines inside of that subderivation because, as I explained, they depend upon the assumption, and the assumption was relevant for the show line for trying to show whatever it was you're trying to show. But once you've shown it, the assumption's no longer relevant. So canceling the show line, you've succeeded in showing it. Boxing it beneath the show line because they may depend upon an assumption. So then, as I said, you have to each show line gets boxed and canceled separately, and so you have to do them separately. So the key crucial strategic point is when you get stuck, do a subderivation. And if you do a subderivation of another right sentence, you'll be able to complete the main derivation. And if you choose a subderivation correctly, it will work, because when you introduce the show line, the new show line, then you get to make an assumption. So you want to watch the indentations. Don't try and move lines back and forth. And you're always working in one particular subderivation, so pay attention to which one it is. It will be highlighted. So here are the basic rules of our derivation system. You always start with a show line. In particular, you want to show the conclusion. You always finish with boxing and canceling that initial show line. And you can write a show line wherever you want, because all that means is you're trying to show something. Now, how do you introduce new usable lines that you can use? Well, first is you can make an assumption. Remember, you can do that only immediately after a show line. You can cite premises, as we've seen, and you can cite inference rules. And finally, you can box and cancel a show line. And once you cancel it, you've shown it, and so you can use it. So that's kind of a two-step thing. First, you say, show this thing I want, and then you do the subderivation, and then you cancel the show line, and then you can actually use what you tried to show. So the basic strategy document, which I mentioned at the end of the previous lecture, that PDF. So there are two strategic guides, sort of strategic helper things. One is the thing that lists all the rules and the assumptions and boxing and canceling methods. The other document is a strategy guide, and if you look at that, it sums up the strategies that I've talked about that I've followed in the different derivations that I've done in these videos. So you're going to want to use that to help you through the derivations. So some important strategies: always, always, always be looking to box and cancel, because that's how you finish the derivation. You never want to show a line you already have. Why? Well, you already have it. So when you complete the derivation, the subderivation, then all you're doing is getting something you already had, which doesn't help you. When you always want to make an assumption after you put in a show line, and then use the basic derivation strategy document that I was talking about previously. The basic approach is you show the conclusion and you make an assumption. If you're trying to show a consequent, then if you're trying to show a conditional, if the main thing you're trying to show is a conditional, then you want to do a subderivation where you're showing its consequent, and again, make an assumption. Once you've got that set up, you bring in the premises and try to do inference rule stuff. And if you get stuck, then you do more subderivations. So I'd like to remind you again, You need to memorize the rules and methods. It's very, very, very important. You don't memorize the rules and methods, you don't know what tools you have, and if you don't know what tools you have, you won't be able to use them. So that's where we are. Your homework exercises for Thursday are derivations and some symbolizations and some rule recognition problems. So good luck with those. If you have questions, let me know. And yeah, good luck.